Good morning, students. In today's class, we'll discuss about the drawbacks of Dalton's atomic theory. In the last class, we discussed about the postulates of Dalton's atomic theory. We will learn about 6 different points. In today's class, we'll discuss about the drawbacks of failure of Dalton's atomic theory. Okay, write the heading: drawbacks of Dalton's atomic theory. Write down this: drawbacks of Dalton's atomic theory. This one is very important and is not given in your NCERT book. Also, here we'll discuss about it. So the first point, that is, in the first point of Dalton's postulate of Dalton's atomic theory, we learned that atoms atoms can neither be created nor be destroyed in a chemical reaction, and atoms are indivisible. Means actually we here in the first and second points we learned that the atoms are indivisible, but in Dalton's atomic theory, we write not in, according to. Okay, according to Dalton's atomic theory, atoms are indivisible. Means atom is the smallest particle of matter and it cannot be divided into simpler parts. Okay, atoms are smallest particle of matter and it cannot be divided into simpler parts. But this one is wrong, because according to Dalton's atomic theory, atoms are indivisible, but atoms can be divided and it contains smaller subatomic particles. Particles like proton, electron and neutron. Okay. So atoms contain 3 different main subatomic particles within it, that is proton, electron and neutron. Okay, these are proton, electron and neutron. How to remember this? Just try to remember PEN. PEN. P for proton, E for electron and N for neutron. So if we break an atom, we will get three main subatomic particles. Some other subatomic particles are also present here, but there are 3 main subatomic particles which are present in atom. These are proton, electron and neutron. कोई ऐसे मत बोलना कि एटम को तोड़ेंगे तो पेन मिलेगा. Here it is pen means proton, electron and neutron. Right? So according to Dalton's atomic theory, that atoms are indivisible, but we know that atoms can be divided and it contains 3 different subatomic particles. Main subatomic particles, these are proton, electron and neutron. This exists within an atom and these are smaller than atom also. Okay, it means the atoms are not indivisible, atoms are divisible. Okay, so here Dalton's atomic theory says. Number 2, according to Dalton's atomic theory, we learned that atoms of same element are same in mass and all other properties. Okay, means according to Dalton's atomic theory, you have to write total, that is D8. I'm writing this D8. You have to write Dalton's atomic theory. Atoms of same elements are identical in mass. Okay. Atoms of same element are identical in mass. Okay. But if we talk about if we discuss about the isotopes. Okay, then you can observe. But in case of 17Cl35, here it should be written like this: 17 left side में नीचे chlorine and 35 left side में ऊपर. Okay, 17Cl35 and 17Cl37, both the atoms are same but have a different mass. Okay, here the mass of this chlorine, that is 35, and for this one that is 37. So they have the different masses, therefore have different masses, but they are the same element. So it is also known, that is according to thermodynamic theory we learned that the atoms of same elements must have the same mass and chemical properties, but here they also have the same chemical properties but their masses are different. Okay. Next one. Next, number 3. According to Dalton's atomic theory, atoms of different element have different mass, but 18 argon 40 and 20 calcium 40. Okay. Both are 18 argon 40 and 20 calcium 40 are different elements but have same mass. Okay. So in case of these two atoms, the atoms are different. Okay, the atoms are different, but their masses are same. But according to the atomic theory, we learned that if the atoms are different, then they must have the different atomic masses or different masses. But where we can observe that these atoms are different, but they have the same masses. This types of atoms are called isobar. Okay, these types of atoms are called isobar. Okay, and where the atomic numbers means here this one is called the 1717. That is called the atomic numbers are same, but their masses are different. Okay, so it is iso 2. Okay, they are called isotopes. Okay, and these are called isobars. Fine, they are isobars to each other. Number 4. According to Dalton's atomic theory, atoms combine in a ratio of whole number. Right? Atoms combine in a ratio of atoms combine in a ratio of whole number to form compounds, but in C12H22O11, that is a formula of sugar, or in some complex organic compounds, although this point will not be clear in this class, you will be able to understand the meaning of this in higher classes. So just try to remember this one. In some complex organic compounds, it can be observed that atoms have different ratio different ratio. Okay, that the different ratio means here the they do not combine in the ratio of whole number. They do not have the ratio of whole number. They have the different ratios. Means the ratio of their masses or ratio of their number of atoms are different. Okay, that's not same, and that's not the whole number ratio. Okay. Next one. According to Dalton's atomic theory, okay, next how many points was it? There is 4. Okay, that's enough for class 9. Okay. The others will be quite higher level, so I am not explaining this more. So I think it is clear that the Dalton's atomic theory is not fully correct. Okay. The atoms are indivisible according to Dalton's atomic theory. That atoms are indivisible, but we know that atoms are not indivisible. Atoms are divisible. You will learn about the drawbacks of Dalton's atomic theory in higher classes in more details. Okay. So this enough for class 9. Let us proceed for the next one. So I think now it is clear that Dalton's atomic theory is not fully correct. Okay. Now in today's class, I am not explaining so much topics. Here I am giving you one very important chart. You have to learn it, you have to remember it. Okay. I am giving you this chart, that is atomic number, name of element, name of element, name of element and symbol. Okay. Next I am giving you this electronic configuration, electronic configuration, valency. In the fourth chapter, we will discuss about it in details also. But here I am giving you this chart, and you have to remember this one. Very important, very important. You will be able to write the electronic configuration, and you will be able to write the formula of some compounds by using this chart. Okay. First, atomic number you have to write 1 to 20. Okay, I am just writing 1, 2, 3, 4, 5. Then write 1 to 20 here. So atomic number 1, name of the element is hydrogen. Okay, having the symbol H. Number 2 it is helium, symbol He. Number 3 it is lithium, Li. Number 4 it is beryllium, symbol Be, capital B small e. It is written Li, capital L small I. Okay. 5 it is boron, boron symbol B. Okay, boron having the symbol B. Next, yeah? Sorry. 4, 5. I'm writing here it is hydrogen, helium, lithium, beryllium, boron. Here electronic configuration I am writing here. There is electronic configuration. Hydrogen contains one proton, there is one electron also. So the electronic configuration is 1. For helium it is 2. The first shell means in the first one, suppose assume there is rooms. Okay, the atoms contain some rooms where the electrons are present. These rooms are called shell. Okay. The name of this, there are 7 shells within an atom. The name of the shells are K, L, M, N, O, P and Q. Okay, K, L, M, N, O, P and Q. This portion is not visible. K, L, M, N, O, P, and Q. When writing the electronic configuration, the symbol is one. In the first room, you can put highest 2 electrons. You can put highest 2 electrons in the first shell, and after that you can put 8 electrons each. Okay. After that you can put just 8 electrons highest. Okay. And so you cannot put more than 8 electrons for the second shell. In the first shell you cannot put more than 2 electrons. Thus you have to write the electronic configuration. Let me discuss. Lithium is atomic number 3. There is 2, 1. The first shell contains 2 electrons and the second one it contains 1 electron. So beryllium it will be 2, 2. For boron it will be 2, 3. Okay, 2, 3. Next. Next. Atomic number. Next 6, 7, 8, 9, 10. 6 it is carbon having symbol C. 7 is nitrogen having symbol N. 8 is oxygen. Okay, it is oxygen written here. Symbol is O. Okay, portion. Okay, this can be visible. It is O, written O. O for oxygen. Don't think this one is 0. It is O. O for oxygen. Capital O should be written. 9. It is fluorine. Fluorine. Symbol F. Okay. The symbol sometimes the students wrote that FL, but it's not FL. It is F. Okay. Next, number 10. It is neon. Neon. The symbol is Ne. Okay. The symbol is Ne. So here the electronic configuration of carbon is 2, 4. For nitrogen it is 2, 5. Oxygen is 2, 6. Fluorine is 2, 7. Neon is 2, 8. Okay. Got it? Next. Next. 11, 12. 13, 14, 15. 11 is sodium. 11 is sodium, symbol Na. 12 is magnesium, symbol Mg. 13 is aluminium. Aluminium, symbol Al. 14 is silicon, symbol Si. 15 is phosphorus. 15 is phosphorus, P. Okay. Let me write their electronic configuration. Let me write their electronic configuration. So here in case of sodium it is 2, 8, 1. We cannot put more than 8 electrons in any shell. For magnesium it will be 2, 8, 2. For aluminium it is 2, 8, 3. Silicon it is 2, 8, 4. Phosphorus it is 2, 8, 5. Okay. Done. Next. Sixteen, 17, 18, 19, 20. 16 is sulfur, S. 17 chlorine. Chlorine is Cl. 18 is argon, Argon, Ar. Symbol capital A, small r. 19 potassium, POTASSIUM. Potassium, symbol K. 20 is calcium, symbol Ca. Sulfur electronic configuration 286. Chlorine 287. Argon 288. Potassium 2881. calcium 2882. These are the electronic configurations. Clear? Fine. Fine. Now while writing valences, just remember, if the last shell of an atom contain 1, 2, 3 or 4 electrons, then it will be its valency. The atom which contain 1 electrons in the last shell, its valency will be 1. And if the last shell of an atom is filled by electrons, okay, then its valency will be 0. And the element having the number of valence electrons or number of electrons in the last shell 5, 6 or 7, to calculate their valency you have to subtract that number from 8. Okay, why we will discuss about it later. Fine. So here I was writing hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Here it is: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium. पूरा एक साथ उस चार्ट में नहीं दिखा पाएंगे, इसलिए हम यहाँ पे अलग से लिख के दिखा रहे हैं. आप लोग उसी चार्ट में ही ये वैल्यू पुट करना. ओके, वैलेंसी, have to write valency. So here in case of hydrogen it contain 1 electron in its valence shell, so its valency will be 1. Okay, in case of hydrogen it will be 1. Helium, it contains 2 electrons in the last shell, and we know that the first shell is filled by 2 electrons, so its last shell is filled, so its valency will be 0. For lithium it contains 1 electron, so 1 in the last shell. For beryllium it is 2, boron 3, carbon 4. In case of nitrogen it contains 5 electrons in the valence shell or in the last shell, so we have to subtract this number from 8, that is 8 minus 5 is 3. Okay. For oxygen it is 2, fluorine 1, neon. It contains 8 electrons in the valence shell. That's why, as we know that the second shell is filled by 8 electrons. So as the second shell is filled, its valence will be 0. Okay. For sodium it will be 1, magnesium 2, aluminium 3, silicon 4, phosphorus 5. Remember, it have one more valency, that is 3. Okay. You will not be able to understand it here, but you have to just remember this. 5, 3. Sulfur 2, chlorine. Sulfur contains 6 valence electrons, so the valence will be 2. 8 minus 6, 2. Chlorine 1, argon 0. Potassium 1, and one more, that is calcium is 2. Okay, now I think it is clear. Sir, how you can prepare this chart of valency? Just I am showing it this. How to remember? First 1, 0. First remember for this two, that is 1, 0. Then we proceed like this: 1, 2, 3, 4, then 3, then down. Okay, 1, 2, 3, 4, 3, 2, 1, 0. Clear? That is 1, 2, 3, 4, 3, 2, 1, 0. Complete. For this one, 1, 2, 3, 4, 3, 2, 1, 0, 1, 2. अच्छा, in case of phosphorus what was written, that is 5, 3. You have to write just 3, 5. Okay, इस जगह पे करेक्शन कर लीजिएगा सब. ये 5, 3 हम लोग लिखे थे, उसमें 3, 5 कर देना है. Okay, now I think it's clear. So these are the valences. Try to learn the name, minimum name and atomic number, like 1 hydrogen, 2 helium, 3 lithium, 4 beryllium, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, 10 neon and so on. ओके, कम से कम 20 तक आप लोग याद कर लीजिए, बाकी जो है वो हम लोग हायर क्लास में सीखेंगे. लर्न आपको दिस. थैंक यू.